This video is part 3 titled Correlation and Regression under the Quantitative Methods of CFA Level 2. In this video, we will cover 6 concepts. The first is the standard error of estimate. Second is the coefficient of determination or R square. Third is to calculate the confidence interval for the regression coefficients. Then we will do a t-test for the regression coefficient. Then we will calculate the value of the dependent variable and also calculate the confidence interval for those values. Let's start with the first concept, which is standard error of estimate. Standard error of estimate basically measures the degree to which the actual value of y varies from the estimated value of y, where y is the dependent variable. So basically what it does is it estimates the fit of the regression line. So if the value of the standard error is small, we say that the fit of the regression line is good, and hence the relationship between the dependent and the independent variable is high. However, if the value of the standard error is high, then the fit of the regression line is low. So mathematically, we say that the standard error of estimate is basically the standard deviation of the error terms. Now, it is very important that you do not confuse the concept of standard error of estimate with SSE, which is sum of squared errors. Both SEE and SSE are measuring the same. They are measuring the degree of the variability of the actual values of y with the estimated values of y. However, they are not the same. Mathematically, if you would like to look at the relation, then SEE is equal to the under root of SSE by n minus 2, where n is the number of observations. The second concept we are going to discuss today is the coefficient of determination, represented by R square. Coefficient of determination is basically defined as the percentage of the total variation in the dependent variable that is explained by the independent variable. So for example, if I have a regression line like this, and this is the mean value of the dependent variable, say y bar, and the predicted value is this, and the actual value is this. Now regression explains the variation of the dependent variable. Variation means the difference between the predicted value and the mean value. So this is basically RSS. This is the variation that is explained by the regression. This is the explained variation. This is the actual value of y, and this is the predicted value. This is the variation which is not explained by regression and is the unexplained part, which is basically nothing but SSE. And the sum of SSE, the error the sum of squared errors, and the explained variation is the total variation, which we represent by SST. Now, what coefficient of determination is saying that it measures the percentage of the total variation that is explained by the independent variable. Means you can say that R square is nothing but RSS by SST. RSS is explained by the independent variable and SST is the total variation. So for example, if I say that R square is 0.85, I basically mean that 85% of the variation in the dependent variable can be explained by the variation in the independent variable. Now, one important thing to note here is that for simple linear regression, you can calculate R square by basically squaring the correlation coefficient. This relationship is true only for simple regression and not for multiple regression. Next, we move on to the concept of confidence interval and t-test. Now, before I move there, I just want to give a background to that concept. We have already seen that we represent a regression equation by y equals b0 plus b1 x. This is the regression equation where we said that b0 is the intercept term and b1 is the slope coefficient, and b1 shows the change in the value of y for 1 unit change in x. Now suppose you want to test whether the independent variable is significant in explaining the dependent variable, which is y. In order to test this, we make use of hypothesis testing. Wherein the basic hypothesis that you are testing is whether the slope coefficient is equal to 0 or not. It means whether b1 is equal to 0 or b1 is not equal to 0. Now you might think that to determine the statistical significance of the independent variable in explaining why are we testing for b1? It is because if b1 is equal to 0, then any change in x will not be able to affect y. However, if b1 is not equal to 0, then change in x will affect y, and we can say that the variable x is significant in explaining the variation in y. Now we can do hypothesis testing in two ways. First is the confidence interval and second is the t-test. Let's start with the confidence interval. So we have already discussed that the null hypothesis is that the regression coefficient or the slope coefficient is equal to 0, and the alternate is that it is not equal to 0. For getting a confidence interval for the regression coefficient, the formula that we use is b1 plus minus critical value of t into SB1. TC is basically the critical two-tailed t value for any given level of significance. So for example, I want to find the confidence in a 95% confidence interval. Then here the level of significance is 5%. Alright, and df is the degree of freedom, which is equal to n minus 2, where n is nothing but the number of observations. SB1 is the standard error of the regression coefficient, which is b1. Now the decision rule for accepting or rejecting the null hypothesis is that if the confidence interval does not include 0, then we reject the null hypothesis. Let us understand how we can get to the confidence interval with the help of an example. So suppose that the slope coefficient is 0.85. So basically b1 is 0.85 and the standard error of the regression coefficient is 0.25. So SB1 is 0.25. The question says that the number of observations were 50. It means n was 50. So the degree of freedom is 50 minus 2, n minus 2, which is 48. We have to calculate the 95% confidence interval for B1. Now, the first thing that we need to do is find out the critical value of t. You can get that from the t table. The critical two-tailed value for 95% confidence interval with 48 degrees of freedom is basically plus minus 2.01. Now for calculating the confidence interval, we use B1 plus minus critical value of t into the standard error of b1. So b1, as we already know, is 0.85. Just substitute it here. Plus minus, the critical value is plus minus 2.01, and you multiply it with the standard error of b1, which is 0.25. If you calculate this, you get a range of 0.3475 to 1.3525. This you basically get from 0.85 plus 2.01 into 0.25, and this is 0.85 minus 2.01 into 0.25. So this is the confidence interval that you get for the regression coefficient. Now, what is the decision rule for the confidence interval? It says that if the confidence interval does not include 0, the confidence interval that we have here does not include 0. Hence, we must reject the null hypothesis. The null hypothesis is that b1 equals to 0. We are rejecting it. So, what we are accepting is b1 is not equal to 0, or that slope coefficient is different from 0. It means that the independent variable x is significant in explaining the variation in the dependent variable, which is y. The same thing you can do with the help of a t-test also. So let's look at how we can do it with a t-test. So here also what you're trying to test for is whether the independent variable is significant in explaining the variation of the dependent variable. So you're testing whether the regression coefficient is 0 or it is not equal to 0. So the test statistic for doing this test is b1 cap minus b1 by standard error of b1. b1 cap is basically the estimated value of b1 which comes from the regression equation, which in the earlier example was 0.85. b1 is this value, so in this case it is 0, and SB1 is the standard error of the regression coefficient. The decision rule here is that you must reject the H0 if t is greater than plus critical value of t or t is less than minus critical value of t. So basically, if you have a timeline and you have a minus critical value of t here and a plus critical value of t here, then if the value of t b1, this is basically t b1, if the value of t b1 lies anywhere here or here, then we reject the null hypothesis. Let's work this out with the help of an example. So we are using the same example as in the case of the confidence interval. Here also the slope coefficient is 0.85. So b1 is 0.85 and the standard error of the regression coefficient is 0.25. So SB1, this is basically b1 cap, and SB1 is 0.25. It is the same thing. B1 cap is same thing as B1. It is just a way of representing that it is an estimated value. Next, number of observations are 50. So n is 50. Hence degree of freedom is 48. As calculated in the previous sum, the critical value of t is plus minus 2.01. So let's calculate the value of the test statistic, which is t b1. It is b1 cap, which is the estimated value of the slope coefficient, minus b1, the value of b1 in the hypothesis, by S b1. b1 cap is 0.85 minus 0 by 0.25. You will get a value of 3.4. Now for taking a decision, we know that the critical value of t is plus minus 2.01. So you have a minus 2.01 and plus 2.01. The calculated value of the test statistic is 3.4, which lies outside that interval. Since the value of the test statistic lies outside the interval of the critical values, we reject the null hypothesis. Since we reject the null hypothesis, we say that b1 is not equal to 0, or the slope coefficient is significantly different from 0, or that the variation in x is significant in explaining the variation in y. So just see that using the confidence interval or the t-test, we reached the same conclusion. So basically you can use any of them to test the significance of the independent variable. Next, we move to calculating the value of the dependent variable. This LOS is comparatively very simple. Here, let's work this out with the help of an example. So suppose that the regression equation that they have given you is this, where Rx is equal to minus 2.1% plus 0.85 into Rm. 0.85 is B1 and minus 2.1% is B0, the intercept term. This is the dependent variable and this is the independent variable. It is asking us to calculate the value of Rx given that the value of Rm is 8%. So basically you have to substitute the value in this equation. Rx is minus 2.1% plus 0.85 into Rm, and Rm is 8%. So we get minus 2.1% plus 6.8%, which equals 4.7%. So 4.7% is basically the predicted value of Rx, or you can also write this as Rx cap equals to 4.7%. Cap just denotes that this is the predicted value. The last part of this video talks about calculating a confidence interval for this predicted value. Let's see how we can do that. We calculate this in a very similar manner as we did it for calculating the confidence interval for the regression coefficient. So instead of regression coefficient, since we are doing for the confidence interval of the predicted value, you have the predicted value here plus minus the critical t value for a given level of significance and standard error of the forecast, which is y. This is very similar. Just to put this in context, in the case of regression coefficient, we had b1 plus minus critical value of t into the standard error of b1. So see, they are very similar. Just in place of b1, you are replacing the predicted value. Okay, so let's work this out with the help of an example. I'm using the same example as we did for predicting the value of the dependent variable, where we used the value of the Rm as 8% and we arrived at the value of the dependent variable as 4.7%. Further, the question says that the standard error of forecast is 3.5. So basically, SF is 3.5, and given the value of the independent variable, we have already calculated the value of the dependent variable as 4.7%. This we did in the last LOS. So we have to calculate a 95% confidence interval for Rx, which is basically Rx plus minus Tc into the standard error of Rx. Rx is basically y because that is the dependent variable. So we will put here 4.7% plus minus the critical value we have already calculated as 2.01 into the standard error of the forecast or Rx, which is 3.5. So just solve it and you will get here 7.035%, and you will get a range as 4.7% minus 7.035% to 4.7% plus 7.035%. If you work this out, you will get a range of minus 2.335% to 11.735%. Now, how do you interpret this confidence interval for the dependent variable? You say that given the value of the independent variable, in this case Rm as 8%, we are 95% confident that the value of Rx will lie between these two values. This is the interpretation of the confidence interval of the dependent value. So this brings us to the end of the video. If you liked it, please subscribe now to Infinity Institute of Professional Studies. Thank you.